Section 1.3, Functions, Definition, Notation, and Evaluation. In this section, we will discuss what is a function, how we can determine if a relation is a function, talk about some definitions, talk about how to determine the domain and range of a function, discuss how to deal with function notation, and how do we evaluate a function. So first, what is a function? The definition that we will use in this course is a function is a relationship between two variables such that for each input there exists a unique output. So let's consider a few situations here. First, is it a function? If the input is the student name and the output is the Valencia ID number, is it a function? So to determine if it's a function, each input must have a unique output. So I would say that this situation does not describe a function. And say, well, why not? Every student has a unique Valencia ID number. And so here's my thought. Two students can have the same name, but they will have different ID numbers. So the input, the student name, suppose just, and for my case, Joel Berman. Suppose that there was another Joel Berman. My student ID number would be different from the other student ID, and so the input, Joel Berman, would have two different outputs, and so it's not a function. Here's another example using a table. If we consider, so here we have a table with values for M and values for P. If we take the input to be M and the output to be P, is it a function? No, it is not. Notice how 20 as an input goes to two different outputs. 20 goes to 100 and 20 goes to 101. So, not a function. What if we take the input to be P and the output to be M? So let's see. Where does 100 go? 100 goes only to 20. Where does 330 go? Only to 50. 95 only to 10. 101 goes only to 20. And so that's okay. We can have multiple inputs going to the same output. That's okay. And we have 200 going to 55. This is a function, because each input, P, goes to exactly one output, M. That's okay. That's a function. Is it a function? If my input is x and my output is y, and we have y is equal to x squared plus 5, is it a function? So the question is, does every input have exactly one output? Well, let's take, for example, what if x was 3? How many outputs would there be for that input 3? Well, notice we have this nice formal definition. The y value would then be 3 squared plus 5, which evaluates exactly to 14. There is no other choice for this. And we could do this with every number. It would get exhaustive, but we could do it. Is this a function? Yes, it is. Let's see this other example. The input is x, the output is y, and we have y is equal to plus or minus square root x minus 4. Is it a function? Well, let's see. What if I let x equal 9? What if I chose that input for x? Then y would equal plus or minus square root of 9 minus 4. So then y would equal positive or negative 3 minus 4. So now y would equal positive 3 minus 4, or y would equal negative 3 minus 4, y would equal negative 1, or negative 7. So my input 9 goes to two different outputs, not a function. And really, we might have seen it right away. Once I saw this plus or minus, that means that there's a choice, that there's more than one way to go with it. And so I knew right away that it wasn't a function. Let's define domain and range. We will define the domain of a function as the set of all possible inputs for a function. The range of a function is the set of all outputs the function produces from the domain. Now, when we're dealing with functions and we see symbols, we see equations, generally, here's what we are concerned about for domain. Our concerns are square roots. We want no negatives under the root. Our other concern are divisions by 0. So now if we look at this one, y equals 3x plus 5, we're asked to determine the domain and range. So the domain is all possible inputs for the function. Well, let's take x to be the input and y to be the output. All right, so let's take x to be the input and y is the output. So what can we put into this function? Is there any number, often we think, is there any number we can't put into this function? Is there any number we cannot substitute for x and then multiply by 3 and add 5? Well, we can do that with any number. So we would say that the domain is the set of all real numbers. Now we sometimes use interval notation to express that, and the interval notation for all real numbers is parenthesis, negative infinity, comma, positive infinity, parenthesis. Now what about the range? What can we get out of this function? Now, we're going to talk more about this graphically later on, but if I were to graph this function, just roughly, y equals 3x plus 5, do this up here in the top right, 3x plus 5 is increasing from left to right, and it continues on in either direction, up or down. And so since it continues on in either direction, up or down, we will say that the range is also all real numbers. Or negative infinity to positive infinity. What if we have the equation y equals the square root of x plus 4? How could we determine its domain and range? Well, let's think about this. Remember, we don't want negatives under square roots. So then we need x plus 4 to be non-negative, which means we need x plus 4 to be greater than or equal to 0. All right, so if we subtract 4 from both sides, we have x is greater than or equal to negative 4. And so what that tells me is that the domain I can write as the set of numbers x such that x is greater than or equal to negative 4. Or I can write the interval notation, bracket negative 4, comma, infinity, parenthesis. So there's the domain. Now, what about the range? Think about how a square root works. We find the principal root. Now, the principal root of a number, of a non-negative number, I should say, is 0 or positive. So what that's telling me is the range, the output, is 0 or positive. So the range I can write as the set of values y such that y is greater than or equal to 0. And I can write that in interval notation as bracket 0, comma, infinity. Determine the domain, just the domain for this one. We have y equals 3x over x minus 6. We call this a rational function, and generally speaking, finding the range for a rational function is fairly difficult unless we have some other techniques, and we'll see some of those techniques later in this course. So we have y equals 3x over x minus 6. Recall that we're concerned about division by 0. So we do not want the denominator to equal 0. So what we'll do is we'll, in a sense, force it to equal 0. So we want x minus 6, we cannot let it equal 0. Well, adding 6 to both sides, that tells me that x cannot equal 6. So then the domain of this function I can write as the set of values x such that x is not equal to 6. I can also write the interval notation for this, and the interval notation would be go from negative infinity to negative 6, close it off. I'm sorry, not negative 6, positive 6. Go from negative infinity to 6, and then union, go from 6 to infinity. All right, so now that we know what a function is, and we've talked a little bit about domain and range, here's the notation that we will use. If a variable y is a function of the variable x, we call x the independent variable. We call y the dependent variable, as y depends on the value we substitute for x. X can generally be any value. It is independent, but the value for y depends on the value for x. We have notation for the functions. The function notation is f of x is y. So again, I said that as f of x. Function of x. Y is a function of x. And so now what does this notation say? Given our input x, we apply the function to x, and the function outputs y. And we often see that in some sort of a little machine or a box. So we input x, it goes through the function, we get the output y. So here's an example where we're going to learn how to use function notation. We're given this function, we're told y is a function of x. And f of x is given by this table, and we see this table of values. We're asked to evaluate f of 6. So 6 is the value for x. It is the input. It is the value for the independent variable. So when x is 6, we apply the function to it. We apply the function. What is the output? When x is 6, we apply the function. The output is 5. F of 6 is 5. Similarly, f of 9 is 7. Find the values of x when f of x is equal to 3. So now, find the values of x, find the values of the input when f of x, hey, that's the y value, that's the output. Find the values of x when f of x is 3. Find the values of the input when the output is 3. So notice that the output is 3 when the input is 5 and when the input is 13. So we'll say x equals 5, x equals 13. State the domain and range. Well, let's see, the domain set of inputs. Well, we only have some specified inputs. The domain is the set containing 3, 5, 6, 9, and 13. The range, notice we have a repeated value in the range. The range is 1, 3, 5, 7, the outputs of the function. Let's continue discussing how to use function notation. Again, y is a function of x, and f of x is now given by this equation. F of x is equal to 3x minus 7. So here our function is in symbols and gives a formula for use in evaluating the function. We're asked to evaluate f of 4. So this formula says when the input is x, the output is 3x minus 7. So if we're asked to evaluate f of 4, the input is 4 and the output is 3 times 4 minus 7. Going through the arithmetic, that's 12 minus 7, which is 5, and so we would say that f of 4 is equal to 5. Second, we have find the values of x when f of x is 12. Now this is, again, the output. When is the output 12? So to figure that out, we would need to find when is 3x minus 7 equal to 12. And this is a linear equation. We know how to solve this. We add 7 to both sides. And 3x equals 19. And we divide through by 3. And that implies then that x is 19 thirds. So when x is 19 thirds, the output is 12. And we're asked to evaluate f of a plus h. Well, earlier we evaluated f of 4. We just substituted 4 in the place of x. Well, now we have an a plus h. F of a plus h would be 3 times a plus h, and then subtract 7. So we'll apply the distributive property, 3a plus 3h, and subtract 7. And that's f of a plus h. Finally, let's use the table feature in our graphing calculator to complete this table of values for, and that should be an h of x, and then we should have an h down here. So we've got this function that has, it's a mess, right? Negative 13.2 times the square root of 2x plus 4 times the cube root of x minus 0.5 times x squared. So let's talk about how we can use our calculator to evaluate this, and we have our inputs are 1.3, 5, 9.26, and 12. Let me bring up my calculator. I'll move it to the left so we can see better. Alright, so I've got this h of x and I've got this formula. Alright, so we do that in the y equals screen. I've got something else there, let me clear it out. So in my y equals screen, I'm going to start typing in the equation. So I'll type in negative. Now be careful, make sure to use the negative and not the subtraction. Negative 13.2. Now the square root is over on the left-hand side. It's the second function of the x squared key. So I'll hit second square root. Notice it opened a parenthesis for me. I'll type in the 2 and the x, close it off. I'll add 4. Now I've got to bring up that cube root. The cube root is in the math menu of your calculator, so I'll hit math, and it's the fourth option. I'll scroll down to the fourth option and hit enter. Cube root of x, close off the radical, and then subtract 0.5x to the second, and so I'll just use the caret 2. So there's my function. Alright, now I have a table that has some different y values. So what I'm going to do now is I'm going to go to my table settings. So I'll hit second and the window key to go to my table settings. And the thing I want to do here is, and most of the time it might look like this. Most of the time your table settings look like this, especially if you haven't used it before. And the only thing I really need to do is I need to go to that independent line, think of independent, my x. I'm going to change it to ask by moving over to ask and hitting enter. I'm not going to change the dependent line. Now I'm going to go to the table by hitting second and the graph button. And it's blank. Well, that's okay. It's waiting for my inputs. So my first input is 1.3. I type in 1.3 and I hit enter, and I get a value. Now this is an approximation. If you go and move your cursor, if you move in the table to that spot, notice that that decimal value goes on further. So I'm going to take it out to 3 decimal places, negative 17.764. Now I'll go back over to the x column and I'll type in x equals 5 and hit enter, move over, negative 47.402. My next x value is 9.26, negative 91.280, and finally, if x equals 12, negative 127.509. All right, that concludes the presentation for section 1.3.